Good morning. Welcome to our notes for Calc 2 on area of a region between two curves. From the opener, hopefully you learned that when you find the area between two shapes, you subtract, and that's kind of the key today. So this is right here is our first formula that you want to write down, is that if we're looking for the area between two curves, we're going to subtract. So a little bit of background: if you have two functions, f of x and g of x, they need to be continuous on an interval that we're talking about. And now if g of x is always less than f of x, then the area of the region bounded by them is the integration of f of x minus the integration of g of x. So it's that same idea of subtraction that you saw in the opener. All right, so let's get into an example and kind of look at how this happens. So if we have a curve y equals x squared plus 2 and y equals negative x, then we have two shapes, and let's get an idea of what those look like. You will want your graphing calculator today, so if you want to go ahead and pause the video and grab that, it's going to be important. So if we have y equals x squared plus 2, that's a parabola, that's up 2. And then we have y equals negative x, and that is a line. Oh, my graphs are not very clean today. Let's try those a little better. So there's my, okay. And we're integrating from x equals 0. So we're going to make that highlighter. So x equals 0, and then x equals 1. So somewhere kind of in there. And we're looking at the area between the two curves. So we're looking at this kind of green section that's between the two curves between 0 and 1. So you've got this section, and that's what I want to find the area of. Now, anytime you hear area, you should think integration. Okay? Now, if they give me endpoints, then the integration becomes simpler because I know those endpoints. So I know what I'm integrating from 0 up to 1. So those endpoints tell me my interval on which I'm integrating. Now, the next thing I need to figure out is which is the larger of the two functions. Which is my f of x and which is my g of x. So as I look at the graph, that's kind of the easiest way to tell. And that's why you're going to use your graphing calculator a lot. So as I look at the graph, I notice that the x squared plus 2 is first. So I've got this function minus function idea happening. All right, so let's see. Ours should be the x squared plus 2 is larger because it's above. And then the negative x is your second one. Now we're just going to integrate regularly at this point. So let's clean it up. We have, oh, come on. It's not letting me slide. X squared plus 2 plus x dx. And when you integrate, not sliding. Okay. X squared becomes 1/3 x cubed. 2 becomes 2x. X becomes 1/2 x squared. And then you can integrate from the 1 to the 0, plug in the 1, and you get 1/3 plus 2 plus 1/2. 1/3 plus 1/2 is, let's see, let's come up here. 1/3 plus 2 plus the 1/2. 1/3 is 2/6. 1/2 is 3/6. So together we get 2 and 5/6. So that'll be our total area for that green little section. All right, let's look at another example. Now, they don't always tell you the endpoints. So like I said, the endpoints are nice if they give it to you. In this example, find the area of the region bounded by the graphs. So this time they don't give me the endpoints, but I can still integrate. I just need to find out what those endpoints are. So if I graph that 2 minus x squared, it's a parabola that opens upside down at 2. G of x is just a line that's going right through the center. So I need to find those two intersections, one here, one down there. You can do it algebraically by just setting the equations equal to each other. So if I set them equal to each other, let's see, bring the x squared over and bring the 2 over. Now we can factor. You could always do quadratic formula also if you don't see the factoring. I do see a factoring. 2 and 1 multiply to 2 and subtract to that. So we'll go a positive 2 and a negative 1. That gives me x equals negative 2. and x equals positive 1. So those are those, here's that negative 2 down here. Here's that positive 1. They look realistic. So that tells me my integration endpoints. So I should integrate from negative 2 to 1. Now I still need to identify which is the larger of the function. It is important that you get that, which is larger, which is smaller. So in our case, the larger will be the 2 minus x squared, and the smaller will be the x. And then you're going to integrate. I'm going to leave you to that. You can do that one on your own if you want to pause the video and go ahead and finish that. Or you can also use your calculator. On the calculator under math, there is an integration button, FNINT. It's the 9th one down. And it allows you to plug in the setup. Let's see. Not that this is one that we really need it for. But when you do, you get an answer of about 4.5. So if you want to check that. Now down here, I've got another question for us to ponder. How could I find a line that will divide that area in half? So sometimes you're tasked with something like that, where I want to find something, like where do I divide it so that the area on the one side is equal to the area on the other. So here's my area in yellow. And if I want it cut in half, where is that magical spot? You know, where is it exactly? How do I know where to find that? Well, if I know the whole area is 4.5, then I know half of that would be 2.25. So what you can do is you can set up your integration. And let's say I'm going to go from negative 2 to some place I don't know. So I'm going to put an A up there. And then I'm going to integrate the same way we did before. So 2 minus x squared minus x dx. But I'm going to set it equal to what I want it to equal. So I want it to equal the 2.25. Now, when you go to do your integration, you're going to integrate just like before. So 2 becomes 2x. Minus x squared become the 1/3 x cubed, and minus 1/2. Sorry, I'm out of room. And then you plug in your a and your b. Let's see, let's get a little page in here. Okay, so we had 1/2. Well, we had 2x minus 1/2, or not 1/2. 1/3 x cubed minus 1/2 x squared, and you had it from negative 2 up to a equal to the 2.5. So plug your a in, we get 2a minus 1/3 a cubed minus 1/2 a squared, and then you plug in your negative 2 minus 2 times negative 2 minus 1/3 negative 2 cubed minus 1/2 negative 2 squared, and it all equals the 2.5. So you've got a lot of cleaning up to do, and you can solve this. 2a minus 1/3 a cubed minus 1/2 a squared. Let's see, minus 2 times negative 2 is a plus 4. 2 cubed, 2 times 2 is 4. 2 times cubed, it would be 8. A negative 2 cubed would be a negative 8, but it's times a negative 1/3, so that'd be a positive 8/3. Negative 2 squared is 4, times a negative 1/2 would be a negative 2. All right, so we bring together all of those. We get 2, subtract that off, 8/3. Oh, wait, let's see. 8/3 is 2 and 2/3. Let's see. That's 2, so we get 4 and 2/3 on this side. Equals 2.5. Subtract that. Now, at some point, you're still going to have to go to your calculator to solve this because it's not going to fit nicely. So let's see. 4/3 subtracted is going to be a negative. Let's see. 2.5. I got 2, it's about 2, let's see. and 1/6. Okay. Now, at this point, you still need to have an answer for your A, but you can use your graphing calculator. So if you add the 2 and 1/6 over, then graph that and find the 0. That's your easiest way. So don't spend a ton of time solving things that you can plug into your calculator. So even all of this, we could have plugged that into our calculator. So it is important that you remember to go ahead and use your calculator. Now, especially as we build into this next one. These two, I definitely would graph. There's no reason to try to graph those by hand. So go ahead and graph them on your calculator. You need to get an idea of what it looks like. So take a moment. You need to graph both of them. We haven't done that yet. And then you're going to look at what it looks like on the calculator. So I'm going to quickly sketch what it kind of looks like. So the area between them looks to be 2 sections. We've got this section over here, and then we've got another section over here. So when you have multiple sections, you're going to have to set up multiple integration. So we have this integral and this integral, one for the left, one for the right. A couple of things that you're going to have to find is the endpoints. So again, it's going to be important that you look for those endpoints. Where do they cross? Those are important. You can use your calculator to also do that. So if you go up to calculate, you can do intersection. That's a nice quick way to find out where they intersect. It looks like the first intersection is at -2, so that will be where we start our integration. It also looks like they intersect at 0, so we'll go -2. Here's my -2. Here's my 0. And then it looks like they intersect, let's see, where's our last intersection? Looks like about 2. Yep, 2. So we integrate from -2 to 0 for this first chunk, plus 0 to 2. So we've got 2 pieces. We want to find them both. Now on both of those, you've got something minus something, because that's that area between. So the area between is the something minus something. So now you can plug those in. Now it's important that you pay attention, because the order does switch. And if you don't do it in the right order, you'll get a negative answer. So it's very important that you pay attention to which is which. So in this first one, the cubic is first. Let's clean this up a little bit. So in here, we're going to put the 3x cubed minus x squared minus 10x first, then the other. Now this one is going to be backwards. This one, the negative x squared plus 2x is first, followed by the x cubed. And both of those are integrating. And you can find their integrals separately on your calculator. Again, use that math button. You don't have to do all this by hand. You could check it if you'd like to. But feel free to use that calculator button to get the integration. All right. Now, this last one has a little added twist. You notice this first equation, that it's x equals instead of y equals. Now you've got some choices. You could either make it y equals, and if we do, we'd make it x plus y squared equals 3, y squared equals 3 minus x. And then when we get rid of that squared, you've got to be careful, because you have to put a plus or minus on it. And it's plus or minus 3 minus x. And so this is, if you graph it, it's looking like a parabola that's sideways. And so 3 minus x, let's see. Yeah, it's coming this way. So it looks like that. And then this one is a line like this. So now when you find the area between them, you're looking in here at this area between them. Always really important on this assignment to graph everything. Get an idea of what they look like, draw it out on your paper, and then find the section that you want. Go ahead and use a highlighter too, and then you're looking for endpoints and that. Now with that, you do switch which curve you want to use on part of it. So it might be tricky to try to make that y equals. So you can also integrate in terms of x. Remember that you can integrate or in terms of y. So it doesn't always have to be the other way. So if you want, you could integrate in terms of y and think of flipping your graph. So we could flip it, instead of it being this way with x and y, we could flip it and think of it as x up here, y here, and then we have a normal parabola with a line. So if you do it that way, let's just switch colors. Then we're going to switch this equation, the y equals x minus 1, and make it y plus 1 equals x. So you can switch it and go the other direction. And then you could graph or integrate 3 minus y squared minus the y plus 1. That's my preference. Now when you do that, when you switch it, remember to switch the endpoint. So now I'm not looking for x coordinates, I'm looking for the y coordinates where they intersect. So it is important that you then look at the y coordinates of where they intersect. You can still find those on your graph. Just switch your variables. All right, if you have any questions, let me know. Your assignment is on WebAssign.